Hi, in this video we are going to talk about rotations. First of all, I'm going to make it private because we are just going to use this height and get balance method inside this class. So there's no point in making this private. Okay, let's save it. So first of all, I would like to implement the right rotation. So right rotation. It's going to get a node as a parameter. Okay, and in this case, if you may recall for the theoretical section, we want to make a right rotation. So the given node, left child, is going to be the new root node. So that's why first of all, I would like to print out that rotating to the right. And I would like to create a temporary node, for example, temp left node. It is basically the root's left child, so it's going to be the node get left child. Okay, child or node whatsoever. Then I would like to create another temporary node as we have seen in the pseudocode, this little t. It's going to be the temporary left node dot get right node. Okay. Then I would like to set the temporary left node that set right child to be the node. What does it mean? This node is the root node of the subtree. We get the left child, basically this temporary left, and we store it in a reference, this temporary left child. And we set the temporary left child set right node to be the node. It means that this temporary left node is going to be the root node. So we have managed to make the rotation to the right. And this temporary node is going to be the root node with the right child, which is this node. So before the rotation, it is the root node. After the rotation, this is the root node. Okay, and this nodes.set left node is going to be this t. Okay, because if you would recall, when we make the right rotation, we rotate this subtree and the result is going to be this subtree. So this is the node in the code and we would like to get the left child. This is the so-called temporary left node. And after the right rotation, it is going to be the root node. Its right child is the original node, which was the root node before the rotation. And as you can see that the B, so the root node left child's right child, is going to be the left child of this D node after the rotation. So that's why we have to set the nodes.set left node to be equal to the T. Okay, and basically we just have to update the height parameters, so node.set height parameter. We have been talking about it in the theoretical section, that it's going to be the height of the nodes.get left node and height of the node.get right node. We get the maximum out of these two height parameters and then we increment this value by 1. It's going to be the updated height parameter for the node. And basically, I'm just going to copy and paste it because the temporary left node height parameter is going to be approximately the same. Of course, instead of the node, we have to specify the temporary left node get left node. So basically, this is the left subtree of the temporary left node and the right subtree of the temporary left node. We calculate the height parameters and we decide that what's the greater and then we increment it by 1. It's going to be the height for these given nodes. Okay, so basically that's all about the rotations, and after that we are going to return with the new root node, which is the temp left node. Okay, so we have the node. This is the root node before rotation, and this is the root node after rotation, the node and the temp left node. This D is the node and this is the temp left node basically, and after rotation the temp left node is the root node and the temp left node's right child is the original root node so the original node basically. So this node is going to be the right child of the temporary left node. Okay, and it's going to be very similar, the left rotation. I'm just going to Control Shift F to auto format. We just have to rename it to left. Of course, rotating to the left. And instead of getting the left child, we are going to get the right child. So it's going to be the temporary right child. It is quite symmetric. The temporary right nodes dot get left node, we have to get the left node, of course. It's going to be the T. Then we set the temporary right nodes dot set left node to be the, so left node is the node, and the node dot set right node is going to be, set right node is going to be this T. And then we just update the height, the math max for the node that get left node, the height of the node that get right node, and we are going to do the same for the temporary right node. Okay, and then we just have to return with the temp right node. It is basically approximately the same, but of course it is symmetric, so whenever we get the left node, we get the right node here. Whenever we set the right node, we set the left node for rotating in the other direction, because basically it is the same. For right rotation, we started with this subtree and ended up with this subtree. For left rotation, as you can see, we started with the right subtree and we ended up with the left subtree. So when we start at the right subtree and we make a left rotation, of course we have to rotate it to the left. So basically this D node is going to be the root node after rotation. So the B is going to be the left child of the root node after the rotation, and so on. So it is very similar, but instead of rotating to the right, we rotate to the left. So that's why the left is going to be the right basically, and vice versa. So that's all about the rotations. Thanks for watching.